Hello everyone, welcome to this video lesson. In this video lesson, we are going to talk about a topic called hypermetropia or long-sightedness, which is a problem of a human eye. Let us say, what do you mean by a human eye problem? For an ideal human eye, the near point is a finite value, say 25 centimeters, and a far point is an infinite value. When the object is at a far distance, what happens? Let us identify. An object is at infinity. Say this is the eye. This is the cornea of the eye, this is the retina of the eye. Being object is a longer distance, light rays comes parallel. They will come and converge on the retina so that our brain is able to identify what is being seen. So the far point is perfectly fine for a hypermetropic eye. But for a near point, if object is kept at least distance of distant vision, that is say 25 centimeters. Let me try drawing a diagram again. This is the eye, this is the cornea, this is the retina. Let us say this is an object here. The light rays from the object will strike the cornea. They are supposed to come and converge on the retina, but they will go beyond the retina. So, being the image is not formed on the retina, we are not able to see the image of the object that is there in front of you. This kind of a problem is called something like a hypermetropia or long-sightedness. Simply to put, for a long-sightedness person, the long distance object is seen properly, but a near distance object is not seen properly. This is the problem. So how do we solve this problem? Simply, the object, if you want to see any object, if you keep it at the least distance of distant vision, that is 25 centimeter, your eye is not able to see it properly. Rather, so this is the least distance of distant vision, 25 centimeters. If it is kept here, it is happening like this. You are not able to see it correctly. Whereas, if we have keep it here at a longer distance, say some value x, the light rays are actually coming and converging properly on the retina so that we are able to see it. But this is the problem. This we don't like it. Keeping an object quite far from the eye and seeing it properly is not a good option. You want to read a newspaper, you want to keep the newspaper at a comfortable distance from your eye, not at a very far distance. So how do we solve the problem? We cannot correct the eye that much easily, and simultaneously I don't want to change the position of an object also. But I will be able to see it clearly only when the object is kept at a distance x. So how do we solve the problem is, we keep a convex lens here. This convex lens keeps the object that you have kept here, takes as an object. That means to say u is equal to d. Even I have to say minus d because light is falling like this. All the distances are measured from the center of the lens. As this distance is measured against the direction of the light, as per the sign convention, it is negative. We will put the lens or focal length f in such a way that it forms an image at a distance x. That means v equal to minus x for that lens, f equal to f itself. Now this convex lens forms an image here at a distance x, which is actually the wrong near point of the eye, but still for the eye, this image of that object act like an object, and the light rays will fall properly and strikes the retina so that you are able to see it correctly. So hope you understand how we are correcting the problem. We are simply keeping the object at the near point itself, that what you would like to see. As the eye fails to detect it properly and forms the image on the retina, we are putting a lens which makes an image at a defective near point, that image is going to act like an object for the eye and you are able to see it properly. So what is the focal length of that kind of a lens I want to calculate? We can write as per lens formula 1 by V minus 1 by U equal to 1 by F. 1 by V is minus X because light is falling from left to right, distance is measured from right to left against the direction of the light. U is also minus, least distance of distant vision is the place where you have actually kept an object. Focal length is positive because you have taken a convex lens. Simplifying this further, minus 1 by X plus 1 by D equal to 1 by F. So 1 by D minus 1 by X equal to 1 by F. D into X, X minus D equal to 1 by F. So F equal to D into X by X minus D. This is the focal length of the convex lens that I need to use, or the power of that lens is reciprocal of that focal length, so that we can solve the problem. So you have a defective near point, you are not able to see the object image when it is kept at D but at a distance X. Then put a convex lens before your eye whose focal length F is this much, so that you will be able to see the image properly. That's it. Thank you for watching. Keep coming back for more and more video lessons. Thank you.